back to another Daishinfinity video. In this video, we're going to talk about something strange about the concept talked about tangent lines. Now, this statement is very interesting. It states that the area of any tangent line touching the function f of x is equal to 1 over x for x greater than 0. And if we would take the triangular surface area that is under the tangent line, it is always equal to 2. And I would like to prove this one for you because this is a very interesting phenomenon, since the 1 over x is a very interesting function by itself already. Now, let's consider taking the function f of x is equal to 1 over x. And let's talk about the function first. Now, the function is an asymptotic function, both vertically and both horizontally. And we can see that the integral of 1 over x is ln of x. So it's a very special function. It creates a bridge between the normal fraction functions into something that has a specific relationship with the number e, the Euler's number. Now, this function is a very special function, and so I can certainly understand why this property is true for any tangent line. And now we're going to take a tangent line over here. So this tangent line touches at a specific point x0 over here. Now, if I touch this point at a specific point x0, which should be greater than 0, okay? Not greater or equal, because equal 0, no, it cannot be working. Now, greater than 0, I'm sorry. Now, if we would take the area that's under this curve of the tangent line, not the area under the curve 1 over x, then it turns out that the area under it, which is a triangular area, that is 2 the whole time. Now let's talk about making the tangent line first. Now, if we want to take the tangent line is a line, so it has a normal description of saying, okay, I have mx plus n. Okay, the m is just the derivative at the specific point x0. So I'll just take the derivative of that function and then put the x0 inside there. Now, there's a specific formula for the tangent line. I'll just want to skip it and then just show you the specific formula for the tangent line. I'll just call it yt is equal to function x0 plus the derivative at x0 and then parentheses x minus x0. Okay, now the function f of x is equal to 1 over x. So the function at x0 is going to be called 1 over x0, obviously. Now, the derivative function is also pretty easy because the function is x to the negative 1. If we would take the derivative, we'll just use the power rule, put the negative 1 in the front, and then minus 1 on the exponent. So we'll get negative x to the negative 2 power, which will equal to the derivative function at x0 being equal to negative 1 over x naught squared. Okay, now we're going to plug all of that in over here. So we'll get 1 over x naught plus, negative 1 over x naught squared, and then parentheses x minus x naught. Okay, now since we have this one, we can just calculate the whole thing. So y of t is 1 over x naught minus 1 over x naught square x plus, because minus minus, now we get x naught divided by x naught squared, so we can cancel 1 over the x naught and we'll get 1 over x naught. And since we have two of them, we can just call it y of t being equal to 2 over x naught minus 1 over x naught squared times x. Now keep in mind that the x naught is the specific point of the x-axis, so it's a specific number. And the x is the variable, so please keep in mind. This is kind of tricky, so please keep this one in mind. Okay. Now this specific tangent line touches at these 3 critical points, so 1, 2, and 3. Okay, now also this one, 4 points. Now the first point, the number 1 point, is obviously the x0 and the f of x0 point, and the other two over here, 2 and 3, are the intersections between the x-axis and the y-axis. And the last one is the 0, 0 point. So considering that x0 is greater than 0, we can first of all calculate the intersection with the x-axis. So I'll just set this equal to 0, and then just solve for x0. So we'll have 1 over x0 squared times x. We'll add the whole 1 over x0 squared times x, and we'll get 1 over x0 squared times x is equal to 2 over x0. Now this 1 over x0 and the 1 over x0 here is going to cancel, and then we'll just multiply by x0, which would lead us to being that x is equal to 2 times x0. What does it mean for us? It means that if we have the function x and y, and the function 1 over x and the tangent line over here, then the intersection with the x-axis is just going to be, okay, let's say this is x0, it's just going to be 2 times that one. So just go one more step, and then we will have 2x0, and at that point, so over here, I'm sorry, that point will be the intersection with the x-axis. To get the intersection with the y-axis, we're just going to take the function again and then plug in 0 for x. So what will happen is we'll just plug in yt of 0, which would mean that we would have 2 over x0 minus 1 over x0 squared times 0. Now anything times 0 is 0, so this will cancel out, and we'll just get 2 over x0. Okay, so in the last we'll get 2 over x0, which is this one. This is 2 over x0. Now we have 2 over x0 and 2 times x0. So the length of this is 2 times x0, and the length of this is 2 over x0. And we have a right triangle since the x and the y-axis are perpendicular to each other. So if we have it, and we have the function, and then we have this line, and we want to have this area here, we would have to take the two sides, a times b, and divide it by 2. That's the area, surface area formula for any triangle that is perpendicular, which is a right triangle. That's what I'm trying to say. So A is equal to, okay, let's see. A is equal to the x length. So it's 2 times x0. Times, we'll get B, which is going to be 2 over x0. And now we're going to divide all by 2. Now what cancels out? Now we see the 2 and the 2 will cancel out, and the x0 and x0 will cancel out. And now you see, wow, the last number which remains is just the 2. Wow. So now we have proven that for any value of x0, it doesn't matter what x0 is, where we put the value of x0, any value of x0, the triangle surface is always the same. So we can always have something like a very long 1 over x, and then we can put some tangent over here which is very shallow, and this area is the same as this area. Okay, it's very crazy. So now you see, math is very, very cool when it comes to these things. I hope you like this video, and yeah, I would obviously upload more of these cool videos, and we'll see us in the next Daishinfinity video. See ya.